Yes, class. So yesterday we had started with moment of inertia. So this we had already discussed all the equations. Torque we had started. Torque's formula was R cross F, right? What is this R? How do we take this R? Abir, you tell me. How is this R taken?
It is perpendicular.
Perfect. Perpendicular. You just drop a perpendicular and that perpendicular becomes the what? R perpendicular. Okay? R.
Yes.
R is taken as R perpendicular. Very good, Abhi. Yes, Alina. SI unit of torque.
Ma'am, can you hear me?
Yeah, say.
SI unit of torque. Ma'am, I can't recall.
What is the formula of torque, Alina? R cross F. I'll tell you R cross F. Now tell me the unit.
Ma'am, no unit.
No unit. Why? Okay, yes, Jesleen, Shaima, Abir, Zainab, correct. It would definitely be Newton into meter. Why no unit, Alina? If I say Newton meter, it means what? This is force multiplied to this is distance. Force is Newton, R is meter. So this is Newton meter. Why no? I think you have not revised then. Yesterday I told you, no, that I'll be asking you questions first, then I'll be starting with the class. SI unit, at least have it in mind, because see, if in your answers you're not writing the final answer with the unit, the examiner will deduct half a mark if everything else is correct. So if there is any issue at any step, see your marking scheme of the paper. The marking scheme is in a way that it divides the question also into parts. If I have the derivation of torque, so the diagram will be having 1 mark, the second step will be having 1 mark, and the final step will be having 1 mark. Like this is how the marks are divided. So even if other things are correct, then at one step you are lagging, so your marks will be deducted. So units are important. Revise the unit. Okay, we have studied that it is an axial vector. Yes, angular momentum. Ali, you tell about angular momentum. What was the formula of angular momentum? Ali Mohammed.
Yes, ma'am.
Yes, Ali, what is the formula of angular momentum? You have also not studied. Jobita, Zainab, Shaima, correct. It is R cross P, that is RP sine theta. Ali, you tell me the formula of P. Ali.
P is equal to mv.
P is equal to mv. So linear momentum is mass into velocity, but when you're talking about angular momentum, radius is also multiplied. It becomes R cross. Okay, the same quantity, it becomes R cross. We're multiplying it. And it's also an axial vector. The direction is, again, see, and yes, I omega. This is new, something new, but this we'll be discussing in today's class. This is left. Yes, Sabiha, what is the formula of moment of inertia? Sabiha. Yes, Sabiha. Sabiha, your answer. Other students have answered also. Sabiha, you're present or not? Are you able to hear in the class? Are you still traveling? What is the issue, Sabiha? You're not present? Yes, no, nothing you're writing. You're writing nothing in the chat column also. Every time there is network issue only. I have removed her. I'll add her after 1 minute only. At least she'll be alert. Okay, so you all were answering. Zainab, Abir, Jesleen, Shaima have answered correctly. MR square. Mass into square of the radius. Correct. Abir, you tell me one thing, that moment of inertia is the rotational analog of which quantity? Yes, Abir.
Yes, ma'am.
Moment of inertia is the rotational analog of which quantity? Like, how can we replace, which term is replaced and put it as moment of inertia I? Answer is there on the screen also. Like for force, I put it as torque,
Yes, ma'am.
right? For displacement, I write it as theta. So all these are rotational analog. So for which quantity in translation motion is moment of inertia being replaced with? Jobita is correct. Yes, Abir. It's written on the screen. I have shared the screen also. See which quantity has been replaced with I.
Ma'am, a
Linear.
linear velocity.
Do you think linear velocity has to be replaced with moment of inertia? Then what is the use of angular velocity? Yes, Alina.
Ma'am,
Just look at the screen, Alina. It's written. If you see it, which quantity has been replaced with I?
M, V.
Yes? Someone answered? Abir has answered or Alina?
Sir, me.
Alina,
Ma'am,
yes. M, correct. Mass. So, no, Shaima and Zainab, how you people are seeing omega? Straight away, the answer has been answered by Jobita. She was right. Mass, can't you see this has been replaced? Yesterday, I was telling you also that mass's rotational analog is moment of inertia, which we have started the class, which we had ended the class. P has been replaced with L. Linear momentum, angular momentum. Linear velocity, angular velocity. Mass, moment of inertia. So yes, moment of inertia we were discussing. That moment of inertia is mr square and it changes with the axis, and this derivation we have come. Mark this derivation important, class. Now see some other quantities also where you see, class, yesterday I told you that if this is asked, ring is there with an axis perpendicular to its center and perpendicular to its surface and passing through the center, we write the formula for circular ring as I is equal to mr square. But class, when you have the axis parallel to the diameter, like this is which case? This is parallel to the diameter. Okay, when this is parallel to the diameter, see, this must be the diameter of the circle. When this is parallel to the diameter, then the moment of inertia is mr square by 2. Okay, this is mr square by 2. So when this is perpendicular, this case is perpendicular to plane and passing through center. And passing through the center. So I is equal to mr square, and for circular ring, I is equal to mr square by 2. You will be getting combination of questions. So that's why these individual, this table, whatever basics I have written, this you all have to remember. Next, disk. Now disk, just slight difference. This portion is the one for perpendicular one. See, if this is the disk, I've just, see, coloring it was in, instead of coloring it, I have just thickened it so you can remember it. This is the same thing, perpendicular to the plane and passing through the center. It is mr square by 2, and when it is parallel to the diameter, it is mr square by 4. Okay, parallel to the diameter, this is mr square by. So parallel to the diameter, here it was mr square by 2. In this case, it is mr square by 4. Perpendicular and passing through the center was mr square for this ring, for the, yes, circular ring. Disk as in, yes, disk as in CD disk. Disk means something which is completely filled. See, difference between a ring and a disk. This is a ring. Disk has all of its surface area completely covered, means there is mass present here also. Mass is present at all these surface. This is what is a disk, means this is completely covered. This is surrounded by mass completely. Okay, so here this is hollow, like you can see, like a bangle. A bangle is like your, or the ring, proper circular rings where the axis can actually pass. You can put your hands inside like this. Disc, this is blocked. It is surrounded by mass. So that is what is disc. Okay, so disc and ring. Then cylinder. Cylinders are similar to your rings. When we talk about hollow cylinder means, if you see from the top, you can see these concentric rings. This part is hollow and only matter is there here. Only there is matter here. If you look from the top means, if you're looking it from here, like this. Okay, so you will see this is the space and this has nothing, no mass in it throughout. That is what is called a hollow cylinder. And a solid cylinder, if you see it from the top view, it will act like a disc completely. That's why the moment of inertia for a hollow cylinder is mr square. See, similar to that of ring. And for a sphere is similar to that of this, the perpendicular case. So this is also how you can remember. This is the case of a ring and this is the case of a disc. Okay. Then comes the sphere. Sphere is a little different. Hollow sphere means it is again concentric. It's like this. This is a sphere. Inside it is also a sphere which is empty. So basically, hollow sphere has just an outer portion. Or best way you can remember for hollow sphere is that this part, it is empty from inside, like a balloon. Hollow sphere is like, see, balloon is not completely sphere. That's why I didn't want to relate it to it. But you can understand like a balloon. If you see a balloon, see, in case of the balloon, this part inside is empty and you just have this outer part. So if you cut it, which is not possible, of course, I know, but if you cut it and you see it, then this is how a balloon will also appear. If you just cut it from here, this portion, if you take transversely, and then you observe it from the top view, you will see it empty. That is what is a hollow. and a completely filled, like the balls, tennis balls, cricket balls. I think these are completely filled. So solid ball means which is complete, which has matter inside also. Okay. This inside this part is also filled. This portion is also filled with mass. That's why you use rho here if you have to use. There is volume occupied here. There is no volume. There is surface area occupied here by the matter. So that's why you have the formula as 2 by 3 mr square for hollow sphere. You have the formula as 2 by 5 mr square for solid sphere. Rod, this case we have derived. And I told you in the last class yesterday that when you have the axis here at one edge, the length becomes L. So same derivation you can perform with x equal to 0 to x equal to L when you will integrate it. So you will get ml square by 3. As it is, you will get ml square by 3. This is ml square by 12. This is again perpendicular to the surface, perpendicular to the plane, plus passing through the center. And here the axis is on one of the ends. So these are standard cases which you have to learn. All these values of moment of inertia you have to learn because you will get the questions. Again, I'll be asking you this, and next time proper Viva I'll take with all the cameras open and you people prepared. If you all are not studying or if you are studying like this. Some students are answering, some of you are forgetting something. So just revise the things which we are doing in the class and then come. Okay, start writing from here. Till here you all have written yesterday. Static and kinetic friction also, they have the unit of force because it's a force ultimately. So static and kinetic friction also has the unit Newton.
Ma'am, can you scroll up?
Okay, see now dynamics of circular motion, the formulas which you just have to convert it. Look, for F is equal to M. I have written all the things which we have discussed, which you already know. Now the new formulas for rotational motion. This formula, the first formula, F is equal to Ma. This formula, this is going to be tau is equal to mass is written as I, acceleration is written as alpha. So tau is equal to I alpha. All remember all these formulas which I am writing. Momentum, linear momentum becomes angular momentum. Mass becomes moment of inertia. Linear velocity becomes angular velocity. Work done. Force becomes torque. Displacement becomes theta. So tau dot theta. Kinetic energy, half is a constant. Mass is I, and angular, the linear velocity is written as omega. So I. All these formulas are very important for your numericals also. This question we'll see. First, you write down both the things, then I'll discuss this. Write it. Okay, class. Now put your pens down. First, listen and then you can copy down the question later. It says a flywheel of mass. Flywheel means like a frisbee. So it's a disc. That's not a ring for us. That's a disc. So it's a case of a disc. So that you can relate it with the moment of inertia. So mass is given. It has a radius. This is radius. This is the mass. What force should be applied tangentially to the rim of the wheel so that it acquires an angular acceleration of 2 radian per second? See, it says that straight away. See, like this, if a tangential force is applied, see, this is the radius, a tangential force is applied so that this starts rotating. See, there must be an axis here. There must be an axis centrally which is passing. So it starts rotating with the angular velocity of 2 radian per second. I think angular velocity or angular acceleration. Angular acceleration. So it starts rotating with an angular acceleration of 2 radian per second square. This is the question. Now, in these questions, do not waste your time in analyzing like how is the force applied so that is it possible that angular velocity is this, angular acceleration is this? No. When you see these questions, everything, understand one thing, most of the data is provided to you already. See, a flywheel of mass 25 kg has a radius of 0.2 meters. Means mass is 25 kg. Radius is 0.2 meters. Angular acceleration is 2 radian per second. This is 2 radian per second square. This is what we want. Now class, to relate it with force, see, you can see force is mentioned. Radius is already given. Force is just mentioned, but radius is already given. Both these things lead to torque. Right? Both of these things lead to torque. Now you have to find out the moment of inertia of a disk. In general, we take this case. See, two cases are possible. One is this case where the axis is passing, and where is this? One is this case where the diameter is just parallel. So which case should we see? When nothing is mentioned, use the case one. Because nothing is mentioned. We don't know where is the axis, where it is taken. Okay. But we just know that force should be applied tangentially and nothing else. We do not know anything about it. All right. So angular acceleration. So basically, you know the relation of torque is equal to I alpha. For this, we want to calculate I. We have to calculate I. I is equal to mr square by 2 for a disk. In general cases, use the hollow ones. For circular ring and all, use the hollow component. But when it is a disk, when you know this will be completely filled, then use this case. Usually this is taken as a standard case. Okay, I is equal to mr square. Let me just put this value here only. Your torque will become mr square alpha divided by 2. Now, torque can be related to the force and radius. Torque is equal to R cross F, or you can say it is equal to R. So this is torque is equal to RF. Now you have two equations for torque. This is first equation. This is second equation. We can equate both of these. So the formula will become mr square alpha by 2 is equal to RF. 1R will be cancelled. We want the force. Now we have the formula for force. We just have to put in the things. So force will be equal to mass is 25 kgs, radius is 0.2 meters, angular acceleration is 2 divided by 2. So 2 cancelled. 25 to 50, 50 and divided by 10 is 5 Newton. So This is the answer. Clear? This is clear to all of you?
Yes, ma'am.
We write down the question also first. Many of you have not written. Write it. Final part means where we have equated. Till here it is clear? 1 and 2 equations.
Ma'am, from the second equation.
Okay. So we have just equated both of these because this is also torque. This is also torque. So we have just equated these two equations. Mr square alpha by 2 is equal to Rf. So radius cancelled. Mr alpha by 2 is exactly the force. So we have solved it. If you are having any doubts how we have got those two equations, then please tell me. I'll explain it. But in the end, in the final part, we have just equated because we have got the values of torque. First equation. Okay, I'll tell you. See, how did we get this equation? Torque is equal to I alpha as discussed here before this, Zenab. Now, value of moment of inertia. This one, for a disk, take the perpendicular one when nothing is mentioned. So this case, this one, what it is? Mr square by 2. So I alpha. I means Mr square by 2. Alpha is the angular velocity, angular acceleration. So when you multiply, it becomes Mr square alpha by 2. That is the first equation.
Ma'am, can you scroll?
Okay, now conservation of angular momentum. So we'll be using this formula of angular momentum, I omega. Now see, conservation of linear momentum, when we were studying Newton's second law, that time it was rate of change of linear momentum. Firstly, this should be very clear to you. P is equal to mv. So P is angular momentum, mass is moment of inertia, V is angular velocity. So class, the way you remember this, we have discussed that when rate of linear momentum is 0, F net or F external, it's better term to use it. F external is 0. So same thing, this is for the rotation. See, dl over dt, that is rate of change of angular momentum. The way it was for linear momentum, rate of angular momentum is 0, in which case when the external torque is 0. So in such cases, if rate is 0, means this must have been a constant, then only on differentiation you are getting it as 0. So angular momentum remains constant. That is I omega becomes constant because the formula of angular momentum is this. This is the main formula which you have to use. It's very, very, very important. This one, this formula, it's very important. See, I1 omega 1, this becomes equal to I2 omega 2. Further I3 omega 3, whatever it is. This is what is conservation of angular momentum. You should understand that product of this should be constant. Product of I into omega. See, when we're talking I into omega, it should be constant. So it means suppose I have I into omega. Okay, I am writing this as a table, just see. So suppose my I into omega, let's say this is 6 or see, I into omega is constant. Now, if the value, let's say here, I1 omega 1 is equal to I2 into omega 2, this is given. Okay. Let's say this is 2 into or 2 into 8. Okay. This is 2 into 8. And let's say this is also something. This has a value, though this is 16, this is 4 into 4. Okay, now the equation is balanced. Now see, something happens and one of the quantity changes. So due to conservation of angular momentum, you cannot have everything intact. Means if I is changing, then this everything cannot be intact. As in, suppose this decreases. So this has to increase in order to make the value still 4 into. If one of these is changing, suppose this is increasing, so this will decrease in such a manner that this remains constant. There are certain applications. Let's see the applications. I think this is, the screen is lagging itself. It's not the internet issue, Zainab. So I think it's because of this only. I think it won't lag now, hopefully. Example, rotation of Earth. Look at this example, rotation of Earth. Earth is there. This is the axis of Earth. It rotates. Okay. This is the radius. Let's assume, let's take a condition. See, if what is the moment of inertia? Moment of inertia is linked with the mass. Let's say the mass of Earth increases. This is the axis. This is the rotational part. This is the axis, right? So suppose mass of Earth increases. So you know moment of inertia, or let's take the opposite case. Let's say this was earlier the mass. Now this is the case. So moment of inertia is decreasing. Okay, Earth has shrunken in size. Let's say this is the first scenario, this is the second scenario. Okay, Earth was this with a greater mass. Now there is a less mass of Earth. Now there is lesser mass of Earth available. So moment of inertia has decreased because moment of inertia is related to your mass, mr square. So what will happen? Angular velocity will increase so much. Omega will increase so much that Earth will start rotating very fast. Why? Because the angular net overall ratio of angular momentum, this has to be conserved. The total ratio of L has to be conserved or it should remain constant. Okay? Or take one more example. Ballet dancers, you have seen or you've heard of ballet dancers. So just one very small example of this is, see, ballet dancers are present and suppose they have their arms spread. Both the arms are spread. Okay. Both these, this is the end. These are the ends of the arm and the arms are spread. Means this is the radius which is greater. So if radius is more, means mr square will be more. It means I is more. Moment of inertia is more. Here the angular velocity is less. Now what did the dancer do? She brought both the hands closer, curved her hands and brought it closer, or properly, let's say properly curled it the way in this manner. Okay, both. So what has happened? The radius has now decreased. So I is now decreasing. So what will happen? She'll spin faster. Let's say the axis. Let's talk about the axis. Let's say this was the axis. So she was spinning here with omega. Now this is the same axis. She'll be spinning with omega. What will be the difference? Now the omega has increased so that the value of angular momentum in both the cases is the same. Both the values of angular momentum initially and finally should be the same. Tell me, any doubts in this? Any part you want me to repeat? Anything? Tell me, class.
Ma'am, if the radius decreases, the mass will also decrease.
Which one, Zainab?
Ma'am, in the second case, the radius is decreased, right?
Yes.
So the mass will also decrease.
Radius has decreased. So see, moment of inertia is mr square. So moment of inertia will also decrease because now radius is decreased. So what will happen? Now, since the value of I is decreasing, in order to compensate it, the value of omega is increasing. That is what is your conservation of angular momentum. Clear?
Yes, ma'am.
What about other students? Only Zainab is listening. Yes, no, you've not understood. You've understood. Any doubts? Yes, class. Clear?
It's
Yes,
clear, ma'am.
Okay. Ali, what about you?
Yes, ma'am, it is clear.
Okay. Okay then, class. Write it from here, and this is a very important topic. It comes for a good marks in your exam, and a little difficult questions are also asked from this. Wherever you see the formula is very simple, like I omega and such simple formulas, the questions are tougher in that part. Okay, then a few questions practicing from this topic, and then more or less this topic is over. We'll start with rolling motion. That will be the last part of it. Rolling motion we'll start here in this only. And for few students, I want to ask, Abir, Ali, Alina,
Yes, ma'am.
yeah, you three. I want to take your extra classes for center of mass. Other students have studied center of mass. You three have not. Jobita, have you studied the class? Were you there in the classes of center of mass, Jobita?
No, ma'am.
Okay, then Jobita, you also. Four of you, because I think Jesleen, Shaima, and Zainab have attended. If they want to attend again, they can. There is no restriction. It will be a revision for them. But for you four, I want to arrange an extra class. So tell me, when can we have? Tomorrow, are you all available?
Ma'am, Tuesday.
Hmm?
Tuesday.
Tuesday?
Yeah.
Ma'am, for me, Tuesday is not possible because the next day I have the first term exam for maths.
When are you having, Alina?
18, I'm having maths exam. So 17 I'll be revising.
Tuesday, it's not. Then Wednesday?
Wednesday, it's fine.
Abir, Ali, Jobita, Wednesday is fine.
Yes, ma'am. Wednesday is fine.
Yes, ma'am.
Yes,
Please
ma'am.
suggest me the timings. Same, 6:30 to 8. 6:30 IST, not this one. This is from 9. 6:30 to 8 early so that we can end the class earlier.
Yes, ma'am.
Okay.
Yes, ma'am.
Ma'am, but I will be in school.
Ali, 6:30 you're not available?
No, ma'am.
So since when can we have the class? That's what I'm saying. Suggest me the timings. Ali, you only say if you're having the classes in school.
Ma'am, I will have school till 6:30.
6:30 IST.
Yes, ma'am.
So when do you come home after the school and everything, when you freshen up yourself, and when can you study? Okay, then
Ma'am,
9 to 10:30 9 to 10:30, same timings. Ali?
yes, ma'am.
Okay, 9 to 10:30, all of you?
Yes, ma'am.
Okay, then Wednesday will
Ma'am,
have.
we have other
Yes, Abir?
Wednesday I have biology class also.
So that's
Same
what